Hi everyone, I'm Adam. In this problem, what we're going to be doing is finding all solutions to the equation cosine of 2x divided by sine 3x minus sine of x minus 1 equal to 0, and find all solutions on the interval from 0 to 2 pi. Now when solving trigonometric equations, as we've done in the past, kind of a general rule of thumb is you want to try to get all of your trig functions on one side, all constants on the other, and try and go from there and simplify. But what we also have is this entire left side set equal to 0. Which from algebra, things that we've done in the past, if you have an equation set equal to 0, if we can somehow simplify and factor, say, this left-hand side, we can set each factor equal to 0 and solve from there. So not being able to look too much into the future from here, we'll leave everything on the left side as it is, except we'll definitely try and simplify what we have, namely our cosine 2x divided by sine 3x minus sine of x. So taking a first glance at this, we see cosine of 2x, right? And we know we have a double angle for cosine of 2x that we could substitute. But if you look at each of those three forms for the cosine of 2x, they all involve sine squareds and cosine squareds. So if we were to make a substitution, we'd get one of those two things in the top. With a sine squared or a cosine squared, we don't really have a way to develop either of those with what we have on the bottom, namely sine 3x minus sine of x. So what we'll do is we'll leave cosine 2x alone for just a moment, and we'll focus on the denominator. So what we have in the denominator, well, we have a difference in signs. So I see some sine 3x, or sine of u minus sine of x, or some sine of v. So we have a difference formula, namely sine of u minus sine of v, we know is equal to 2 times the cosine of u plus v over 2 times the sine of u minus v over 2. So like we said, starting with just the denominator, we'll try and simplify there. So the left-hand side is going to be equal to the bottom, using the right-hand side of our formula, 2 times cosine of u plus v, or 3x plus x all over 2 times the sine of u minus v, or 3x minus x all over 2. And our numerator is still cosine of 2x. And here we're subtracting 1, and this is all set equal to 0. Okay, so let's take a look. So we have cosine in the denominator of 3x plus x divided by 2. So 3x plus x is 4x divided by 2. Gives us just a 2x. And in sine, we have 3x minus x, which is 2x, divided by 2. Will leave us with just an x. So this can be rewritten as cosine 2x in our numerator, all divided by 2 times cosine of 2x times sine of x, and minus 1 equal to 0. So what do we see? Well, actually, as it turns out, this cosine 2x we're not going to have to worry about after all, because this cosine 2x will cancel with this cosine 2x in the denominator. And that's going to leave us with 1 over 2 sine x minus 1 equals to 0. So let's take a step back for a minute and reevaluate what we have. So we've simplified to 1 over 2 sine x minus 1 equal to 0. So we said, yes, we have an equation set equal to 0. If we could factor one side, we'd set each factor equal. But if we notice, we just have one trig function sitting on the left-hand side. So here I think it's going to be easier to go with the other route. We'll get the trig function on one side and all constants on the other. So what can we do? Well, let's bring the 1 over by adding it. So we have 1 over 2 sine x is equal to positive 1. And now to solve this, right, we have the trig function on one side, but solving equations is always easier when the thing you want to solve for is in the numerator's position. So we can get sine x, say, upstairs if we multiply both sides by sine x. And what that will give us is, on the left-hand side, our signs will cancel, so we'll have 1/2 equal to sine of x. Okay, and what are we looking for? We're looking for all angles x in the interval from 0 to 2 pi that will give us a sine value of 1/2. So namely, that's going to be x equal to pi over 6 and 5 pi over 6. So our solutions to the equation cosine 2x divided by sine 3x minus sine of x minus 1 equals 0 are x equals pi over 6 and 5 pi over 6. Now we're going to use a graphing utility to graph the equation and verify the solutions. So we had cosine of 2x divided by sine of 3x minus sine of x minus 1 equals to 0, and we found that the solutions on the interval from 0 to 2 pi were pi over 6 and 5 pi over 6. So we have our equation, and since it's set equal to 0, what we can do is graph the left-hand side, cosine 2x divided by sine of 3x minus sine of x minus 1, and we should see that that graph will cross the x-axis at the values pi over 6 and 5 pi over 6, meaning that the y value is 0. So we'll go into our equation input, and typing in cosine of 2x divided by the quantity, meaning all in parentheses, sine of 3x minus sine of x, close parentheses, and minus 1. And if we're not there, let's make sure our mode is in radian mode. And let's set the window before we get to our graph. So we'll go to our window. Since we're concerned, we're just looking at where the solutions are on the interval from 0 to 2 pi, we'll make our x min 0 and our x max 2 pi. And since our solutions are multiples of pi over 6, we'll make our x scale count by pi over 6. So each tick mark on the x-axis will be counting by pi over 6. And we'll make our y min -2, y max +2, and the y scale just counting by 1. So now we're all set, and we can press the graph button. Now as you watch it being graphed out, we'll see the function, the graph of the function, go through the first tick mark, which is 1 pi over 6, and through the 5th tick mark, which is 5 pi over 6. So confirming that it's crossing the x-axis at those points, or that the y value is equal to 0. Now that's visually, and there's one more thing that we can do to confirm this. If we use our trace feature, putting in trace, and for an x value, we can type in pi over 6 and press enter, and it'll show us that at pi over 6, y is equal to 0, meaning the graph is crossing the x-axis at pi over 6. And likewise, using our trace feature again, type in 5 pi over 6 and press enter, and it should give us a y value equal to 0, again confirming that the graph is crossing the x-axis at 5 pi over 6. So we have that the solutions are pi over 6 and 5 pi over 6. Thank you very much.